Hello, welcome to another episode of the RPG and Go tutorial series. Today we're going to be adding a scene management system to our game. Up until now we've been working with just one little dummy scene, but most games have at least a start menu, so we need to have a way to manage different compartmentalized parts of our game, whether it be the start menu or the pause menu, or just different parts of the world, the overworld, maybe going inside of a house. We need a way to actually switch between those, and so that's going to be the topic of today's video. But before that, if you're following this series to a T, I made some slight changes. I converted all of the times where I said 16 to tile size. So if I look for everywhere where I say 16, there's only two spots where I declare a constant, and here is actually 116. So it's no longer in our code so that we can easily change the tile size whenever we need to. With that being said, let's go ahead and get into it. So the first thing I'm going to do is I'm going to define what a scene is. And so for that, I'm going to first create a new directory, and I'm just going to call this directory scenes. And inside of here, I'm going to make a new file called scenes.go, and I'm going to save that, go into there, and let's go ahead and get started. Okay, so the first thing I'm going to do is I'm going to put the package scenes because we're in the scenes package, and then I'm going to define what a scene is. Now, if you think of a scene in kind of like a movie sense, a scene is just like a little section of the movie, but it has the properties of a movie. It's still playing, there's still people acting and all that sort of stuff. And so if you think about a scene in a game, a scene still needs to update itself, it still needs to draw itself, it needs to probably load in some assets and unload some assets. So we're basically going to treat this as like a miniature game object. You know how we have that game struct where we have the update and draw methods and we have a constructor for it? We're basically going to do a very, very similar thing for every single scene. And so for this, I'm going to create a scene interface. So it's going to be type scene interface here. And now we have to think about what we need to do. So we had those requirements as stated earlier. So we need to be able to update ourselves, draw. Let's see, it needs to be able to first load in. This will be for like loading assets and stuff. We need to have an on enter, which would have for passing a signal between them whenever it's transitioning to another scene. And then we would have an on exit for the exact same reason. So now that we have the basic, structure of what a scene is, we need to also define what needs to be passed between each. The draw one's simple. We just need the EBA10 screen to draw to, just like normal. So EBA10 image here. And the update one's a little bit interesting. So the way that I like to structure scene systems is I like to have the update method return the state of the game after it has been updated. And what that means is basically I like to return whatever the next scene ID should be. Most of the time, the scene will just return its own ID, which means that we keep on staying in that same scene. But sometimes it'll say, hey, I want to go to this scene. So it'll return a new scene ID, and then the scene manager will pick up on that and say, hey, I need to switch scenes, and then it will do that. And I found that is the simplest approach for my own use case. So let's go ahead and add that here. So I'm going to say type scene, and I'll call it like a scene ID here, and I'm just going to say uint, and then I'm going to declare some constants here. So this is going to act as our scene IDs. The first one is going to be my game scene ID, so game scene ID. This will be of type scene ID, which will equal iota, which is how you declare the smallest of an enum. And then I'm going to have, I'm going to have a start scene ID, so start scene ID. And it will automatically increment. So if we check this, game sanity is 0, start scene ID is 1. So that's exactly how we want to do that. And now what we can do is inside of our update method, we can say that it returns a scene ID. Okay, so we have the framework for scenes implemented. We now need to have a scene manager. And so a scene manager, we can actually just put it inside of our game struct here. Okay, so now that we have the scene interface kind of mapped out here, why don't we create our game scene? So I'm going to go in here inside of our scenes directory, and I'm going to create our game scene. So game scene.go, put it in there, package scenes, and then we want to say type game scene struct. And then we need to implement all those methods that we outlined earlier. And a cool little shorthand, if you have a modern editor with some LSP information and all that sort of stuff, you can put in this shorthand to get auto completion for it. Kind of like in Rust, where it will autofill the missing methods that you need to implement an interface. So I'll say var underscore of type scene equals, and then we want to do, I think it's asterisk game scene parentheses nil like this, and then we'll have this error, cannot use game scene as scene. And what we can do is we can actually use a quick fix, which will declare the methods of the scene. And now we have them all declared. Now they all have panics with unimplemented in them, but we can just get rid of those because we will implement them here. So that should be all good. We'll just get rid of all of these, get rid of the comments, and now we should be good to go. And so our game scene is literally just going to be our game. So we can actually just go into game.go and let's just take all of this stuff. So as this is a tutorial series, this will have a lot of things that are series specific in it, but the actual core fundamental ideas of the scene management system are going to be there as well. So if you're just here to learn how a scene management system works, there will be timestamps in the description to kind of cut to fundamental areas to avoid the code refactoring and all these sort of things that we have to do because we're making a comprehensive game. With that being said, hopefully you enjoyed the tutorial and learned something new. Let's get into it. We need to add in all the stuff that's in our game struct. So not to confuse the two, the game struct is actually the game itself. The game scene is just like the gameplay scene. So I'm going to be grabbing everything inside of the game struct and putting it inside of the new game scene. But before that, I have to make some changes. And the reason is because I put the tilemap.json, the tileset, and the camera inside of the main package, which if you know anything about Go, whenever you have a package inside here, like constants or scenes that's in a deeper level than the main package, you can't import things in that direction. You can only go in directories, you can't go back out of directories. And so because of that, we need to pull this stuff into their own smaller packages. And that's as simple as just making the directories and changing the prefix whenever we're using them. So I'm going to create one here. I'll just call it, tilemap like this. And we need to go in here. I'll just take the tilemap, take it out of that, go into tilemap, paste it in there. I go back, create a new one for tileset. So tileset here, cut the tileset, put it in there, go back. So we'll do the camera as well. Go over to the camera, go up to the camera folder, paste it in there. And I think that should be good. So now what we can do is we can just go into all those new files, change things around from package main to package camera for this one. And then for the tilemap one, it would be package tilemap. And for the tileset one, it would be package tileset. Finally, we can go into that game struct here. And now we're going to have a lot of errors, but it's okay because we're moving it out of this file anyways. So I'm just going to take it from the game struct, go to my game scene.go, and then paste it inside of there. We're also going to get some errors here, but a lot of them are just import errors. So we can say we can resolve all the imports here. So which Go does automatically for us. So that's very, very nice. For tilemap.json, this now exists inside of the tilemap package. And then for tileset, it exists inside of the tileset package here. And then the camera is in the camera package, so we can add it there. And now that we've resolved all the imports, we should no longer have any errors on this file, except for the missing return on update. Now let's go ahead and go back to the game struct, the game.go file here, and let's pull out the stuff that we put inside of the update method. So I'm just going to select everything inside the update method, copy that, and then go to the game scene, go to our new update method, and paste it in there. Now there is going to be one more error for the constants, so I will resolve that. And then instead of returning nil, I will instead return the game scene ID, because that's basically saying we want to stay inside of this game like this. We also need to import the math library here, and then we need to import the format library like that. And that should be good to go for now. Now we want to copy the contents of our game struct's draw method here and go into our game scene and go to that draw method here and paste it in there. We'll have to resolve the color import, so just add that import in there, and that should be good to go. The next thing that we need to do is we need to handle initialization. Now initialization is going to be a little bit different than it is with the game struct. In the game struct, we're actually creating the game object and loading in the assets at the exact same time, which we don't really want to do here. And the reason is because imagine you were playing a game and whenever you first started it up, all of the assets for the entire game loaded in at once. Maybe for small games, that's okay. But for larger games where you have, gigabytes of assets to load in, that's not something you want to do all in the very beginning. So what we need to do is we need to separate it out. We need to initialize a game scene with no assets loaded in, and then whenever we actually need to use the game scene, then we will load all the assets in. So we can go to our game scene here, and let's add a little constructor function for this. So I'll say func new game scene, and this will return a game scene object. And all we're going to do here is return everything with their own default values. So we will return a new game scene like this, and then for this we will say that the player is nil, the player sprite sheet is nil, the enemies is going to be, and we can actually initialize this, so we can say we can make an empty array here, and then we can say the potions is going to be an empty slice here, and then we can say the tilemap JSON is going to be nil, the tilesets is going to be nil, the tilemap image is going to be nil, the camera is going to be nil, and the colliders is going to be an empty slice. So yeah, it looks like the game scene is pretty useless at this point, but that's because it's basically just a placeholder, and then whenever we actually need it, which is going to be the first load method, that's where we're going to load all of our assets in. So now what we can do is go back to our game.go and just basically take this new game here and copy all of the contents, but we're going to be heavily altering how we create everything. So I will go back to our game scene, and for now let's go into that first load and just paste everything as it is, resolve the imports. And so after we load all of these assets in, instead of returning a new struct at the end of first load, we will simply assign the values of these fields inside of this method here. So I'll say g.player equals, and then we want to take in this player here like so. So cut that out, paste it in here. And then we can get rid of the return statement altogether because they have all been covered. So it's essentially just the constructor, but it's kind of like a delayed initialization of some things, and that's just for some performance optimization when first starting up the game. So we haven't actually added any functionality yet, but now what we can do is we can essentially just clear out our game struct, which we can then use for managing our scene. And so after clearing out everything from our game struct, it should look something like this, basically empty. And so now we can actually use it for managing scenes instead of just using one default scene inside of it to begin with. There was quite a lot of movement in that previous step, I know, and so if you do need help with that, I will have the source code available for this tutorial in the description, so you can look at it. It's essentially just porting everything over, but it is switching that constructor to being a delayed initialization of things can be a little bit confusing, but just reference that if you find yourself a little bit stuck. Now back to the actual topic at hand, which is the scene management system. How can we manage our scenes? Now, it's actually really not that hard to manage scenes if we have our scenes already set up. What we can basically do is inside of our game struct, we can just have a map of all the scenes in our game, which I can just call our scene map here. So scene map, which is just going to be a map of scenes dot scene ID mapped to a scene interface. Then we can have another variable, and this will be our active. Scene ID, which is just going to be a type scenes.sceneID. Now inside of our new game constructor, we can assign scene map to a new map of scene ID to scenes, and then inside of there, we will say scenes.GameSceneID maps to scenes.newGameScene like this. This means that we have one scene inside of our game, which is our game scene, and it maps to an empty game scene object like that. And then we can say that our active scene ID is going to be equal to our scenes.GameSceneID like this. Then instead of doing all of our update logic directly inside of the update method of the game struct, instead we will just do this little bit of code, which is next scene ID equals g.scenemap at g.activesceneID.update. And then in order to actually do something with this next scene ID, we'll just say if next scene ID does not equal g.activesceneID, that means that we have switched scenes. We can then actually grab a pointer to the next scene by saying next scene equals g.scenemap at next scene ID. And then we'll say if, and then we need a way to check if the scene has already been loaded in or not. So we need to say if not loaded, then load in. And so in order to do that, we need to make a modification to our scene interface. So I'll go to that scenes.go here, and we will have a getter. So we'll say, let's see, is loaded, and this will simply return a Boolean. And that means that we need to also go into our game scene here, and we need to add a new property to our game scene, which is going to be a loaded Boolean here. And then I will add a little function. So func g game scene is loaded, and just return the g.loaded like this. And I'll also, for good practice, assign it to false explicitly in the constructor. And then instead of our first load function, we will go to the very end and then say g.loaded equals true, because after it first loads, it is now loaded in. So now what we can do is go back to our game.go, and then we can say if not next scene dot is loaded, then we want to do next scene dot first load. And no matter what, we always want to call that onEnter function so that we can send a signal to it. So we'll say next scene dot onEnter. And then we will also do g.scenemap at g.activeSceneID dot onExit. And then finally, at the very end, outside of the if scope, we will say g.activeSceneID equals the next scene ID. And then return nil for our update function because it expects this error here. Now you might be noticing something with this, and that is that there's no clean way to exit our program right now. And so there is a little bit of a workaround that I use for this, and it's a little bit of a bad practice, but I find that it's extremely easy, and it's honestly the absolute easiest way to do this. And basically the way that I exit out of scenes is I go up here and I add a new enum to our scene ID that is exit scene, like this. And then you would go into your game here, and basically you would just have another check. You would say if next scene ID equals scenes.exit scene ID, then just exit. So return ebattension.termination. You might also want to do g.scenemap at g.activeSceneID on exit like this. But basically that's how you would do it. You would just have a special scene ID for your exit scene that would allow you to quit whenever you want to. This means that in our game scene, if we wanted to exit whenever we press Q, we can do this. We can say if input util dot is key just pressed ebatten dot key Q, then return exit scene ID. And that's how you would do it. Now there are just a couple more things we need to add. So in the draw here, the draw one's a lot simpler. We would just say g.scenemap at g.activeSceneID .draw like this, and then pass in that screen. And then that should basically be everything good. Now there is one more issue that we have, and that's the check collision horizontal and vertical are both inside of the main package. But for now, I'm just going to pull those into the scene package just for simplicity purposes. So we'll cut those out or then go at the bottom here, and I'll just paste them in here for now so that we can resolve those issues. And then we need to resolve just a couple more issues where the moving around of files did affect some things. So for example, inside of tileset, we need to actually prefix it with tileset like this. And then we can remove these unused imports, and we should be good on errors. So now we can actually test this and see if I missed anything. So I'll do go run dot. Oh, right, I forgot. There is one caveat with this system, and that is that we do need to actually load in the first scene explicitly, because we're calling update before we call first load. And so what's actually happening here is that we basically assume that the very first scene in our game is loaded in explicitly. And so what we can actually do is we can pull out the initialization of everything in new game into their own variables like this. And then we can just pass them in like this instead. But now what we can do is we can say scene map at active scene ID dot first load like this, and then that should cover the issue that we had there. Okay, and now we have this thing here and we can move around. All is good there. And now what we can do is we can like click on stuff and we should see that things are perishing, which is great. So it looks like we haven't lost any functionality, which is some pretty cool stuff. But in order to actually demonstrate a scene management system, we need to actually have multiple scenes. So I'm going to create another scene. So I'll go into our scenes directory here and let's actually add in a start scene. So start scene.go here. Go into package scenes and let's create it. So type start scene struct. We need to have in that loaded state here. And then we need to actually so then we can do type start scene struct. We need to have in that loaded boolean so that we can return it inside of the isLoaded. And then we need to implement the methods of scene. So var underscore scene equals a pointer to a start scene that is a nil pointer here, space CA, declare missing methods, get rid of every panic. So just do that. Get rid of all of the comments like that. Return the start scene ID from update, return s.loaded from isLoaded, and then create that constructor for start scene. So func new start scene here, and then this will return a pointer to a start scene object, which will just return a very simple start scene, which will have loaded set to false. Then we need to say inside of first load s.loaded equals true. Instead of draw, to show that we're in the start scene, I'm going to do screen.fill, color.rgba, and then inside of here, I will do a nice red. And then after we fill the screen, I'm going to put, let's see, ebitin util, I think, ebitin util dot debug print, and then I'll put it on the screen. And for the string, I'll say press enter to start. And then inside of the update method, I will say, if input util dot is key just pressed ebitin dot key enter, then instead of returning the start scene, we will return the game scene ID. And then inside of our game.go, instead of setting the active scene ID to game scene ID, we would set it to start scene ID, and we need to add an entry in here for the start scene. So start scene ID and then scenes dot new start scene. Okay, now we can actually run it with go run dot. And as you can see, we have a press enter to start like this. We can then press enter and we are now inside of our game. Pretty cool stuff. Finally, we should probably add like a pause scene. So what I'll do is I'll go into here, I'll go to our scenes, I will create a pause scene.go file. And let's just go into our start scene here and let's just copy everything from that. Go to our pause scene, and I'm going to do a very quick find and replace on this. And so if you're in NeoVim, which I'm glad you are, we can replace start scene with pause scene. So pause scene like this, and then do a little GC to make sure we're not overriding too many things. And I think I will just accept all of them. Great. And we do need to actually add a pause scene into our scene IDs here. So we would add it here with a pause scene ID. Okay, go back to the pause scene. And then instead of saying press enter to start, we would say press enter to unpause. And then whenever we press enter, we go back to the game scene. And in order to actually hook this up to our game, what we need to do is go into our game scene and then go to our update method. And then we would say, if the enter key has been pressed, then we want to go to the pause scene. And then I'm just going to change one more thing to make sure that we know that we're in the pause scene. So I will change this from a red to maybe like a green or something. So, all right, so go run dot. We are now inside of our start scene. We press enter, and I have an error because I think I didn't add inside of here. Yep, so I need to put that this is the pause scene ID, and that this is a new pause scene. Okay. Press enter, walk around and stuff. We're paused. We press enter to unpause. Great stuff. And what's cool about it is that the state of the game does not update while we are paused in the background. If we did want it to update, we could simply embed a scene inside of a scene, which is actually really, really easy to do. But as you can see, you know, the skeleton is paused and while we are in the pause menu, which is, you know, pretty cool accidental functionality. So that was probably the most amount of code change that we've done in one singular video, but we implemented an entire scene management system with a skeleton start scene and skeleton pause scene. And we have some simple scene switching and, you know, exit management stuff. In future videos, we will cover global state management across these scenes so we can send signals from one to the other. And we will also clean up some stuff a little bit. But now it's looking like our project is in a really, really good shape, especially since our, you know, main package is very lean now and everything's kind of compartmentalized in these, you know, sensible little packages here. And so not only did we implement a pretty cool scene system, but we made our project a lot more structurally sound in the process. But that being said, I know that this was a very involved tutorial that took a lot of focus because of all that moving around. So again, I recommend checking out the GitHub, which will have all the source code as well as explaining the changes. And so that should hopefully help out with the confusion there. There should also be a little bit of documentation in the README for the changes, but hopefully you understood the actual core idea of the scene management system. It's not as hard as some people say, especially with this very, very simple example here. So hopefully you enjoyed and hopefully you learned something new. If you did, consider liking and subscribing. Also consider joining my Discord, which has a ton of developers that would love to talk to you, and it's a great place to ask questions and to learn new things. And also consider supporting me on Patreon so I can continue making videos like this for y'all. Thank you very much for watching. Have a good day. See ya.